Hello and welcome to my channel. I am Bearded Dev, and in this video we're going to be looking at the performance of aggregate window functions. The script I'm going to go through is available in the description for you to follow along. Now, first of all, we're just going to simply check if our orders table currently exists in the database. If it does, we're going to drop that table. We're then going to create our orders table. That's going to consist of OrderId, which is a big integer. It's going to have an identity property, so the values are automatically going to be generated for us, and it's got a primary key constraint on that column as well. We also have CustomerId, again that's a big integer, and an amount as a decimal. We're then going to be setting some variables. Now the customers variable is going to be simply how many customers we have within the data, and the number of rows is going to be how many rows we're working with. So feel free to play around with these variables and you'll see where they're used in the query shortly. Now we're going to be using cross joins within CTEs, which effectively creates exponential growth in terms of the number of rows. I don't want to spend too much time on how that is working, as I will do a separate video on that. As we can see down here as well, we're going to be selecting the top number of rows, and in this case that's set to 1,000,000. Once we've got those rows, we're going to be dividing those rows by the amount of customers using NULL. And if you're not familiar with NULL, I have done another video on that on my channel, so I will leave a link to that in the description as well, so feel free to check that out. Now for the amount, I wanted to generate a random value. I didn't want to have to do anything fancy there, I just wanted a random value to be created. So a question for you watching this video, and feel free to leave your answers in the comments, is within SQL Server we have a rand function which generates a random number between 0 and 1, but you can apply some mathematical calculations to that. So why couldn't I use that here? Or rather, I could have used it, but what would be the impact of using rand function within this large insert of 1,000,000 rows? What would the results have looked like? Now what we're doing within here is we're creating a new ID, which is going to be a unique identifier. We then use checksum, which takes that value and converts it to a checksum value. We then have absolute to convert that to a positive, and then we're dividing that number by 1,000,000 and then converting it as a decimal. So if you have any questions about that structure, do let me know. So if we go ahead and execute this query now, it's going to take a few seconds to run because it is creating 1,000,000 rows within that table. And once that's done, we'll just do a few simple checks of, we'll run a count of how many rows are within that table. Well, we can see there are 1,000,000 rows affected, but we'll just run this count anyway. Yep, so we've got 1,000,000 rows, and then let's just do a select top 1,000 just to give us a feel for what the structure of the table looks like. Yep, so as we can see, we've got OrderId, we've got CustomerId, and we've got a random amount. So the next thing we want to do is have a look at writing out some queries that compute the percentage of the value as a row against that customer's total, and also the total of the table. So we're going to do another select, we're going to return CustomerId, and to return amount, and then we're going to return amount over the entire table in this case, and that's going to be our percentage of total. and then we're going to return amount over, again, some amount, but in this case we're going to add a partition by CustomerId, and that's going to be a percent of customer total. That's going to be from our orders table. So let's go ahead and execute this query and have a look at what those results look like first of all. So the first thing is our percentages are not very, in fact they're not correct, because we'll need to multiply the value by 100, but they're not very tidy. So first thing we'll do to resolve this is we'll multiply the amount by 100 just to get a correct percentage value, and then we're simply going to cast the result as a decimal, and we can see here with the percentage of total we need quite a large number of decimal places to get any meaningful results. So I'll put 6 on, and we can have a look at what that looks like. Let's rerun that query. So our percentages now look a lot better, but this video is not about creating aggregate window functions. And when I talk about aggregate window function, I'm talking about your simple aggregate functions as sum, min, max, average. This is not about the performance of things like lag or lead or first or last value. So now we're going to take a look at the execution plan for this query. So there's a little icon here, or we can press Control M on the keyboard. So we're going to include the execution plan, and we also want to delve a bit further. So we want to have a look at some statistics for this query as well. We want to understand how long the time is actually taking. So we do have this time down here of how long the query takes, but that's how long it takes for us to send the query off and get the results back. I'm actually working on an Azure SQL database here, so it's not this machine that the SQL Server is sitting on, so there is some transfer of data between that server and my machine I've got doing this work on. So first of all, we want to have a look at the time statistics to see how long this query is taking, and then we also want to have a look at the number of pages being read, and once I run this query it will be a bit more clear as to what they actually mean. And again, if you've got any questions about these, please do let me know in the comments. I'm trying to move through parts of this video quite quickly, and at the end we have to set the statistics off as well. Okay, let's execute the query. It is going to take a bit longer, so you might see in your bottom right hand corner of your query execution time that increases, because it's also got to return things like the execution plan and the statistics to us. So that query is executed now, and the first thing we're going to take a look at is the execution plan. Okay, so I've opened the execution plan up, and we can see first of all we're going to be scanning our orders table. That's going to move 1,000,000 rows in this example. We're going to be computing an aggregate function, computing scalars. There is a sort operation here which is going to be quite expensive in the cost of this query to allow it to compute the percentages by customer, I would imagine. There's also some parallelism going on here, as we can see by the little yellow icon with the 2 arrows pointing to the left. So all in all, that query actually looks okay. That's what we'd expect to see. We're picking up the data once and we're just computing the values as we move along the execution plan. If we have a look at the statistics, we can see in terms of the logical reads, so the number of pages red with data on. It's quite a low amount for 1 million rows, which we'd expect because the rows are quite small, so I wouldn't expect them to take up many pages. And the total elapsed time, 1411 milliseconds, which I believe is 1.5 seconds. So overall that's performing exactly as we would expect. But of course we can't just end the video there, there's got to be something else we look into further. And as I mentioned, I am connecting to an Azure SQL database. So we're going to have a look at the properties of that database, and in particular the compatibility level. So I've opened up the database properties, I'm going to click on options, and we can see up here we've got the compatibility level. And the database I'm using has the equivalent level of SQL Server 2019. Let's now change that to SQL Server 2017, compatibility level 140, and execute the same thing. So again, we're going to include the execution plan, we're going to include the statistics. If we execute the query, that will take a few seconds to run, and once that's completed we will take a look at the execution plan. And remember, all we've done here is effectively change our version from SQL Server 2019 to 2017. That is it. We haven't changed the amount of rows, we haven't changed the structure of the query. And if we have a look at the execution plan, we can see that things are now a lot different. As opposed to 2019, when we were looking at just a simple line straight from the table to get to the result, we can see now we've got within the query execution plan, we're again looking at the table, but we have these things called table spools. And if we have a look at the table spool, we can see what it's doing here is storing the data from the input into a temporary table in order to optimize rewinds. So what this query is telling us is, I'm going to go to the table and read all the rows, but then I'm going to put those into a temporary table, and then I'm going to keep reading from that temporary table. We can see the number of table spools within this query. I think there's 4 in total, as well as the creation of that. Actually there's 6. So 6 from the table spool. We can see we've lost the ability to run the whole query in parallel. It's only at this point that it starts to run in parallel. And if we have a look at the statistics for the query, we can see the total execution time is now way over 8 seconds. And if we have a look at the number of logical reads, we can see that that is now huge, almost 5 million logical reads there. So obviously we have a big gap in performance between what's in the performance in the database engine between SQL Server 2019 and SQL Server 2017. And the same would apply to any prior version, so any version prior to SQL Server 2017. So we've got a query now that is not optimal. So what can we do about this? Well, another way to rewrite this query is, if we have a look at it, is if we can compute the total sum amount for the table and the total sum amount for a customer, and then compute the percentages, then compute the amounts over those values, we might have a better chance. So how could we look at optimizing this query to improve our performance? Well, let's have a look at writing this out an alternative way. So to get a total for the table, we simply select some amount from dbo.Orders. To get the total for a customer, we'd simply have CustomerId some amount from our orders table, and then of course there we're grouping by CustomerId. Now how could we put this all together? And we could use derived tables or CTEs here. So I'm going to select CustomerId amount, and then we're going to have amount again times 100. Let's say from dbo.Orders. So I'm just trying to construct this in a meaningful way, and we'll give this an alias as A, and we're going to just change the order of these tables. So that's going to inner join to this query, which is going to be our derived table. I'm going to alias that as B, and we're going to join on A CustomerId equals B CustomerId. So we join into this derived table here. So you can run this independently to test. So we're going to be taking the CustomerId from here and joining it onto there. So we must make sure we're aliasing these. So we want that as A amount, that as A amount, that as A amount, and then that's going to be over. Let's give this separate alias over custtotal. Now we don't need to do any aggregate functions here because that's already done within the derived table. And then again we will cast this result as a decimal value. And we have 86. It's going to be percent of cust total. And then we are going to cross join to the total table, because the reason we're cross joining is because we want to return that amount for every row in that table. The difference between the other one where we inner joined on the CustomerId was we only want to return the right total for each CustomerId, whereas with the total, so the total for the whole table, we actually want to return that per row. So again, what we want to do is cast a amount, multiply that by 100 over total as decimal 86 as percent of total. So we have here the equivalent functionality. We have a derived table here that's returning a customer and the amount per customer. Another derived table, I just like to indent derived tables, and another derived table here computing the total for the whole table. We're cross joining to this one because every row, every one of those million rows, we want to have that total, and then we're going to compute again the percentage. And then CustomerId is slightly different, as we're going to be only want that total for matching CustomerIds, and we're just going to simply set the equivalent and have a look at the performance. So first we'll set the statistics on, and then we're going to set the statistics off. We're still including the actual execution plan. So let's go ahead and run this query. And the first thing we want to check really is, are our results looking okay? And I can see from the rows that we're returning already, they look about where we would expect them to be. So that query is finished now, if we have a look at the execution plan, and again it's not quite as optimum as our performance in SQL Server 2019 using the aggregate window function, but what we're doing here, look, is we're hitting the table 3 times. Here it looks like we're computing the total row. Here we're probably computing the total row per customer, and then at the bottom we've got the details row. Again, our query is now running in parallel. There's probably some more optimization we can do to this, like we're getting a message to say an index is missing, but we're hitting the table 3 times, as opposed to when we use the Windows aggregate function, was hitting the table once, taking a copy of that table and storing it in tempdb, and then hitting that table numerous times. And as further evidence of that, we can have a look at the statistics. So the execution time is just under 3 seconds, and if we have a look at the number of logical reads, remember we was almost at 5 million previously. We're now down to 16,000, which is much more performant. And just to emphasize a bit more, so what we're returning here, so we'd expect 1,000 rows because we've got 1,000 customers, so we've got the totals per customer, and then the last query, let me just bring this down slightly, and then the other query will just give us the total. Let's just hide that. So if I was to just comment this out and just do a simple select all, we can see what we're actually building here. So we can see now we've got the customer total, but let's scroll down where that customer ID changes, and we can see, we can see how that customer total changes per customer, whereas the total stays the same because we're cross joining on every single row. So really hope you have enjoyed that video. Like I say, all of this will be available in the description for you to follow along. Now, it's not to say that if you're using SQL 2017 completely avoid aggregate window functions. If you're only working with a small amount of data or producing ad hoc queries, in other words, you're writing it as a one-off, it's not something that's going to be stored and regularly queried, then window functions are a lot simpler to write, and you may not see a huge amount of difference in performance. If you're working with large amounts of rows like I've done here, I've purposely scaled the amount of rows to highlight performance issues. Of course, that's the issue gets magnified the more data you're working with. Then it might not be a concern for you, but it is something to bear in mind, and I hope you have enjoyed having a look at execution plans and the statistics. Any questions for me or any videos you'd like to see in the future, please leave a note in the comments below. If you have enjoyed the video, hit that thumbs up button, subscribe to the channel if you haven't already. Once again, thanks a lot for watching.